let's say that we have a process, a YT, that follows an AR1 process, and this means that it's following an autoregressive process of order 1, which means that we have one lag. So YT is only dependent on YT minus 1 and not any further lags like YT minus 2 and so on into the past. And let's say that the population regression coefficients, or the population model coefficients, are known. Then our forecasts for the next period value of YT, remember that capital T is the end of our data set. It means that this is the last known value of the y variable is for time capital T. But we would like to know what's going to be the value of YT in the next period. And based on what we know, we can just plug in the current value here in our model, in our AR1 model, and we have the population coefficients, and we can just calculate this scalar, this number. But the problem is that the population model coefficients, they are not known. So we use ordinary least squares to estimate the betas, the slope, and the intercept. And sorry, now we get a y hat for time t plus 1, which is the estimated value of y at time t plus 1 given, so this bar here is given information at time capital T, right? Because we have observed the y variable from time 1, time 2, and up to time t, and we have this these data points, and we would like to make an estimate for time t plus 1. So this is our problem, or our question. So mathematically, we just write y hat t plus 1 given information at time t. So, and what we do is that we have this observed value, and we have the OLS estimates that we have used, that we have retrieved from running the ordinary least squares regression on YT on its YT minus 1 lag. And let's say that this beta naught is 10 and the beta 1 is 0.9, and the YT was, for example, a stock price, and it was 50, right? So then you would have 45 plus 10 equals 55. So that would be your estimate. Okay, so this would be kind of your estimate for time t plus 1, given the information you have at time capital T. In the last slide, we made our guess of the stock price of for time t plus 1, right? So, but probably we are not going to make a perfect forecast. So if this is our y variable and this is our time, and we made a guess for the stock price at time t plus 1, so this is our guess. And what if the guess was 55, right? But what if the stock price did not move, so it came in at the actual, let's see if we can write that, actual equals 50, right? In this case, we have made a forecast error. And the forecast error is the difference between our forecasted value of 55 and the actual value of 50. So a good forecast will, on average, be quite close to the actual values, but in order to calculate how good your forecast actually is, you have to find a series of forecast errors. And in our case, the forecast error was the actual value minus the forecasted value, which means that we had a forecast error of -5. And it's quite important that we realize that our forecast is made at time equals to t, because this is how much information we have, okay? And we can only observe the forecast error when we actually arrive at the time of the forecast. In this case, at time t plus 1. It's important to note that the forecast into the future, given this was given information up and including time t, is not the same as the regression or the predicted value from the regression. And the forecast error is not the same as the residual from the regression. Because if we have the y variable here, we have time here, and we have data from day 1 and so on up until day capital T, and we have our data points, and our regression is run by using these observed data points, which are in sample data, and we use this model and its estimated coefficients to forecast into the future, for example, for time t plus 1, and the data that we get into the future, and we can compare our to which we can compare our forecast, is out of sample data. This means that the out of sample data is not used to estimate the model, and this is why we can use the model to predict the values in the future. and we can compare them with the true value when we get there. And the residuals from the in-sample estimation, because you have, for example, yt here and yt minus 1, and you have, if you have plotted them, you can often get, for example, we had 10 here, we had 0.9 slope in our example, and this is the y hat for yt, right? And this is the fitted line for yt, but these residuals from the true values to the fitted line, they are not in general equal to the forecast errors, because we do not use the future value of y to estimate the regression coefficient. So the forecast might be biased and have other problems, but this is one major difference between the OLS predicted value and the OLS residual, and the forecast errors and the point forecast. So what I mentioned on the previous slide, the forecast, the point forecast, and the forecast error, they are out of sample, which means that we did not use these data points to estimate the coefficients in our forecasting model.